Welcome to Sketching Angles in Degrees. Yes, we're going to be doing radians tomorrow, so that was a little bit of a lie. Sorry. All right, so today we're going to identify and sketch angles, tell you what coterminal are, and convert degrees to radians tomorrow. Okay? Alrighty, so here we go. First thing you have to know is we are going to be sketching angles on the coordinate plane. The coordinate plane is that x and y axis that we're always dealing with here. So, where is it? Here it is. This is the x and y axis. Here's the x, here's the y. Now, when we have those two axes and they hit each other, they create four quadrants. So, the sections created by the two axes. Okay? That's the sections, and we can even go so far as saying the four sections created by the two axes. Hopefully you remember the origin, that's the where the axes intersect. And the four quadrants. So the four quadrants are created. Remember, I always think about it as the C in the coordinate plane. It starts here. This is quadrant 1. Then it goes to quadrant 2, quadrant 3, quadrant 4. And if you don't write them as Roman numerals, then it is wrong. So you do have to write 1, 2, 3, and 4 in Roman numerals. It starts here and goes in a big C, or counterclockwise, when we name them. And hopefully you'll realize why in a second. So we're going to be sketching an angle in what's called standard position. So we have to have a standard position so we don't all go crazy and draw angles anywhere we want, because then no one's would be the same. Okay? So the vertex is always at the origin. Okay? So the vertex is where the two sides meet. That's the vertex spot. Okay, the initial side, where the angle begins, that's always on the x-axis. Let me move over a little. It's always on the x-axis. So it's always on the, and let's be even better, the positive x-axis. So what I mean by that is, remember, all the values over here on this side, that's positive x, right? Over here on this side, this is negative x. Let me erase that. That's negative x. So the positive side, that's always your initial side. We don't even have to draw it. We just look at it. We know it's there. It's the terminal side that we really focus on when we have to draw. The terminal side is where the angle ends. Think of terminal, ends. You go to the terminal at an airport, that's where your flight ends. Okay? Now, one of the things that we say a lot, determine where the angle terminates. This is something that we say all over and over, and that simply means determine what quadrant the angle ends. Or where is the terminal side? I don't know. I made that up just then. So, and then when we sketch an angle, it's important that we put the arrow saying that that's the direction that we measured it. And if you think, all right, so direction that you measure is related to counterclockwise or clockwise. That makes a difference. All right, so counterclockwise is the first way to measure, and counterclockwise is the positive direction. So if you have a positive angle, it's going to go in counterclockwise, and if it's a negative, it's going to go regular clockwise. Okay, so it's all related to the initial side and the terminal side. So let's talk about that now. All right, so if we have an angle here, I don't really know what it you know, how it's been measured. I know that my x-axis here is one side, but it could be an angle that goes like this, or it could be an angle that goes like that. Okay, we're not really sure, or it could even go around a few times and then end there. So that's the problem with this. So we need to know what direction, if it's clockwise or counterclockwise, so we can kind of figure out approximately what the degrees are. So I think I figured something out here. All right, so if I take this guy and I go this way, this is the counterclockwise direction, and this is a positive rotation. Okay, that's positive. Watch, it's going to do that. That is the positive direction. Now, if I go, you didn't see that. If I take this guy and I go start here, this is the initial side, the x-axis, and then I go around the axis this way from the initial side down, that's negative, that's clockwise. Okay, see how that works? So that is a negative rotation. All right, now you can stop. Okay, now the other things that you need to know, quadrantal angles are angles that are on the quadrants, like on the axes. So that's a quadrantal angle, that one, and that one. Okay? So if you want to think about it, from here to here is about 90 degrees. All right, so the quadrantal angle, not about, it is 90 degrees. 90 degrees is one quadrantal angle. Going all the way over, that's 180 degrees is another quadrantal angle. So all the way to here. And then all the way around to there, that's 270. And then all the way to 360, that's another quadrantal angle. So any multiple of 90 degrees are quadrantal angles. Another way to say it is that it's angles that terminate on the axes. That's, you know, another way of saying what a quadrantal angle is. All right, so we just talked about that a little bit. What are the degrees in each quadrant? Now, when I'm talking about this, we do tend to focus on positive and one rotation. So that means I'm going to say angles between 0 and 360. Angles will terminate in quadrant 1 with an angle of like 380 degrees, but I'm not going to care about that right now. Okay? We'll talk about that in a minute. So the angles in quadrant 1, quadrant 1 starts here, that's 0 degrees, and it goes to 90 degrees. So right at the y-axis, that's our 90-degree quadrantal angle. So in between these two, that's quadrant 1. Remember we said this was, we labeled our quadrants. So quadrant 1 is between 0, and we're calling it theta because that's our thing, and 90 degrees. Notice no underline. Okay, it's not equal to 90 or equal to 0. Okay, because 90 and 0 are not in quadrants. They're on the axes. So there that is. So quadrant 2 goes from 90 to 270. Oh, nice, to 270. Awesome. To 180. So this is 180 degrees here. Going down a little bit farther, that's 270 down there. So between 180 and 270. And then quadrant, that's here to here. And then here to here, that's 270 to 360. So those are the quadrants that each of the angles are. Remember, we are going to discuss negative and all those kinds of things, but for the positive angles, and which most generally we will be talking about, those are the quadrants. Alrighty. So then we have to discuss coterminal because it's an important concept because, as I have been alluding to, if you have one angle here, like 120, it could also be, if we go the other direction here, negative 240. Okay? Or you could go around in a circle a few times and then go back there. So remember, if you go in a full circle, you're going 360 degrees. So from here all the way around is 360. But also if you start at this side and go another 360 degrees around, it's going to be a circle. So that's the idea behind coterminal angles. Coterminal angles are angles that end in the same place. I have 270 in there. So end in the same place. Okay? In the same quadrant and on the same line. So their angles terminate in the same spot. So what other angles are coterminal to 120? We'll just take a second and add 360 to 120 or subtract 360 from 120. And you can just keep doing it over and over and over. So if I take 120 and I add 360 to it, I get 480 degrees. But then I could add 360 degrees to it again and get 840. And I could add it to again and get 1200. These are all coterminal to 120 degrees as long as I added right. Pretty exciting, right? Okay, but you could also subtract. So 120 minus 360 is negative 240. And so I could take negative 240 and subtract 360 and get negative 600. These are all coterminal because they all end in the same exact spot. They all end right there. They just kind of going around in a circle a few times and ending there. So that's all that means. So if we want to sketch some angles, we take all those things into consideration when we sketch. Okay? So the first thing is it starts here. Now you don't have to draw that because everyone knows the angle starts there. Then if the angle is positive, it's going to start here, obviously. Just said that 10 times. And it's going to go up. Okay? If it's negative like this guy, it's going to start here and go down. And it's important you know that. Positive angles go up or counterclockwise. And negative angles go down or negative clockwise. Or, whatever. You know what I'm saying. Okay, so 65 degrees. When we sketch, it doesn't have to be exact. Don't need to get your protractor out and your fancy little rulers. You're all good. 65 degrees. What quadrant are we going to be in? We just talked about that. 65 degrees is in the first quadrant. You can be somewhat accurate, but that looks good. That looks like 65 to me. Okay, remember your center or your vertex right there has to be on the origin. That's 65 degrees. But how do I know that it's not this angle or this angle that goes around 10 times? Well, because I put a little arrow and I say, okay, I'm going to start at the x-axis and go up and put a little arrow that says that's my measure. Done. Negative 115. All right, so here you might have to think a little. So this is negative 115. This is when we're on. So this is the x-axis, is where it starts. We don't have to draw it. But I'm going to start here and go down. If I go down to this spot, I go down to 90. If I go all the way over to here, I go to 180. So this is negative 90. So negative 115 is going to be somewhere in here. Again, doesn't have to be exact. Just kind of sketch it out. But I need to know that it started at this axis and went down, and that's how it measured it. Oh, you should label. When you're labeling this was too small here, sorry. When you're labeling just one angle, how necessary it is, I don't know, but it's definitely a good idea. So negative 115 degrees. Now, if you do something that's bigger than 360, you're going to go around the circle a few times. So I do suggest to you is to find out what angle that we kind of recognize is 570. So what I would do is subtract 360 and see where the angle is going to terminate. So if I subtract 360, I get 210. Okay, 210 makes more sense to me. Excuse me. 210 would go around here. Again, it's positive, so it starts here and goes up. This is 180. Going down to around here-ish is where 210 is going to be. So, again, 210 and 570 are coterminal. So they're going to end in the same spot. So that was just a tool for me to show you, or, to figure out where the angle terminates. So the problem with that is I have to show that it went around in a circle. So what I do is I start my arrow, I go up, I go around, I have to go 360 degrees. Okay, so it went around in a circle, and then it came over and looped to 210. So that's how you have to show it. You have to kind of do a loop-de-loop. A one loop for every 360 you go. Negative 390, again, it's a negative, so I would add 360 to find an angle that would make sense to me, and that's negative 30 degrees. Now, I can understand negative 30 if you don't. Add another 360 and get the positive equivalent. So negative 30 goes here. So remember, it starts on the x-axis here, and it goes down 30 degrees. Okay, the only problem with that is it's negative 390, not negative 30. So I start here, I do a big 360 loop, and I go to the angle. Make sure you put the arrow, negative 390, and I always forget, so remember eventually. Okay, to label. Have a nice day.